Welcome, dear students, to your number patterns lesson. In this lesson, we are going to do the quadratic sequence. Here, it's actually the second difference that will be constant. So we are going to dive right into this lesson and see what I'll be expecting of you this time around. All right, so if you look at this number pattern that I put for you in advance over here, right here, I hope you can see where I am. Now you have 1 and 4, 9, 16, 25. I think if you're guessing what I'm doing, you will say 36, and you carry on from there on. So it's not difficult to notice that we'll be talking about perfect squares there, like this one is 1 squared, the other one is 2 squared, that one is 3 squared, and that's 4 squared, and that's 5 squared. So really, if I want to get the general term, I may go ahead and say n squared without thinking much. You see, if I want to get any term like T10, I can just say 10 squared, and I'll be able to get 100. So this one is as simple as it looks, but you see it's the beginning of the quadratic sequence. You can see that it's a quadratic. Well, now, what is it that we use to identify a quadratic sequence? Well, notice it is actually the second difference that will be constant. So look at these differences here. I'm going to say 4 minus 1 is a 3, 9 minus 4 happens to be a 5. So I am going to make sure you see the differences here. Okay, and then here there is 9. So this lesson is your second lesson on number patterns. If you didn't do your linear number patterns, please go ahead and check that video out first. Okay, good. So here you can see that if I subtract 3 and 5, that's 2, and that's 2, and that's 2. So in this situation, it's only the second difference that is constant. So that's one thing you should know about a quadratic sequence or a quadratic number pattern, is that the second difference is constant. So that's precisely what you must know. So even if you have a sum such as this one, let's see if this is quadratic or not. So calculate the first differences and see. Here, the first difference is 3. You say 7 minus 4, then 14 minus 7, it's again 7, and here it should be an 11. When you go and subtract again on these ones, notice you get 4 here and you get 4. The moment the second difference becomes constant, that's how you know you are dealing with a quadratic number pattern. And therefore, it will be easy for you to find the next term because the second difference is constant. Well, let us see now how to get the general term. You know, if you want to get more terms in this number pattern, it will be very simple to get to the next term in any number pattern. But if you want more terms, you may need what we call the general term, such as this one, the Tn formula. So for this particular one, you see we didn't struggle to get the general term while dealing with that one. But for this second one, we cannot quite guess it easily, like just figuring out what Tn is equal to instantly. So I want you to appreciate the fact that we are going to use the formula, a quadratic formula, which says an squared plus bn plus c. Well, you already know that a quadratic itself normally looks like ax squared plus bx plus c. This is what we are used to. But now we are dealing with terms, so we're just changing our x to n. I think that's the only thing we are going to do. So we want to find a formula or a way of determining the general term of a quadratic number pattern for each sequence. So let's go ahead and use this thing here to get a formula for everything. Well, if you look at what we have here, I put these terms here in advance for us to use. So look at the general term that I talked about here. So if I may ask you to find T1 using that formula, you are most probably going to say A, in place of N you put 1, and then in place of N again you put 1, and then you say C. As you can see, that will simplify to just A, that will simplify to B, and that will simplify to C. You know what? I put those ones in advance for you. This will represent T1 right there, A plus B plus C. Well, just so you can get used to it, I'm going to do 2 more terms for you so you can see If I wanted to get T2, I was going to say A by 2 squared plus B by 2 plus C. As you can see, 2 squared will be a 4 here, and this will be 2B, and this one will be C. Well, that would be your second term, isn't it? And as you were expecting, it is right here. That is your second term, 4A plus 2B plus C. Well, just for the love of it, let's do T3 now. I think you're getting the hang of it. So it's A, and then you put 3 squared plus B, and then you put 3, and then we say plus C. As you can see, if I want to express T3 in terms of A, B, and C, it will be like this. It will be 9A, because 3 squared is 9, 9A, and then that will be plus 3B plus C. As you can see, this one is the term that we've got over there. I'm not going to carry on to T4 and do exactly the same thing. I just wanted you to have an idea where I got these terms up here. So this one will be your T2 and this one will be your T3. I think even if you substitute 4, you'll be able to get that one as I did. Well, if you remember, all the time we were calculating the differences between the terms. We will go and say T2 minus T1. So I would like to erase the things that I highlighted. So at this point, I want us to say this T2, which is over here, minus the T1 that's there. So let's start by saying 4A minus A. I think you're seeing how we will get our 3A there. So this should be 3A here. And then if you say 2B minus B, you should get your B. And then C minus C, it cancels. Well, do the same for this ones. Subtract these two terms. 9A minus 4A, you should have your 5A here. And then 3B minus 2B, you should definitely just have a B. Well, you had them before. Let's just subtract these two so we can get our first differences. 16A minus 9A, I think you're seeing where the 7A came from. And then 4B minus 3B, that would be yet another B. Well, if you have the terms such as these ones, if you do it, you see we decided to just see where it's coming from. Look, now this is now my second differences. So I'm going to say this 5A minus 3A. Notice I'll get my 2A. And again, if I say 7A minus this 5A again, I'll get 2A. So I managed to express the terms in terms of A, B, and C, and also the differences, the first difference and the second difference in terms of A and B. Well, and C, it's just that C was cancelling all the time. So in this situation now, I think we can now form a few basic rules that we can use whenever we want to calculate an unknown. So here is what I want you to remember. Always remember, I'm going to erase this part unfortunately. For every sum you are going to have from now on, just know that the second difference of that quadratic pattern, 2A, it should simply be equated to the second difference all the time, just like what I've already indicated here. Okay? It's very, it may appear fancy when we start off, but you will see that it's quite nothing at all. And then this, we are simply going to use these three to get the formula. This one, that one, and that one. That's what we need to determine the formula. So we have already talked about 2A, right? What about 3A plus B? You just equate it again to the first difference. So I think it would be better if I do it while showing you what I mean. So let me pick up that question over there. We had 4. Let me put it here, 4. Then we had 7, 14, and in fact everything is already done, so I can as well just copy it fast. There is no need to talk about it. We did that already. I'm taking it from our left hand side here. I hope you can see what I'm doing. Okay, so we are taking the 3, the 7, and the 11, and then this one is 4, and this one is 4. Okay, so what am I saying in this situation? I'm saying if you would like to get the equation or the general term of this number pattern over here, you just have to use these three things I circled. How do you use them? Go ahead and say 2a is equal to the second difference. In this situation, the second difference happens to be 4. And then you go and you equate. Do you see the 3a plus b in the original? This one right here? It is in the position of this one right here. So you equate that one to 3. And while you're still at it, look at where a plus b plus c is in the original. So you can see a plus b plus c can be equated to the first term. So that one in this situation, it will be equal to 4. So what do I want you to know? 3a plus b equated to the first difference. In fact, is the first difference. Because on the second term, you can see that we have quite a number of differences. We also have 5a plus b and 7a plus b. But I'm saying take the first one, this one. And then, of course, a plus b plus c is going to always be equated to the first term. So that one is not going to be an issue. So I think the only place you have no problems with understanding what's going on is here and there. It's given. Your second difference just equated to 2a. Your first term equated to a plus b plus c. Well, understand this. The first difference, the first difference right there. So that's the one you equate to 3a plus b. Just like what I did. I equated that to 3 and I took the 4. So you take those three terms all the time. It's actually very simple once you get the hang of it, but let's go ahead and find the equation of this one in particular. So I am going to go and say, since our 2a we have already agreed is equal to 4, so what it means is that our a now is going to be equal to 2. I already have my a. Now let's see if I can get my b. So we're going to go and put a of 2 there, plus b is equal to 3. So what it means is that you say b is equal to 3 minus 6, so that should be negative 3. And then now you go and substitute those two into this last equation. So you always use these three equations. So you can as well just remember them off by heart. 2a, 3a plus b, and also a plus b plus c. It's very simple like that. It works for every quadratic equation. Not equation, pattern. So that would be 2 minus 3, that's negative 1. When you take it to the other side, it should be equal to 5. So your C value is equal to 5. Don't forget, your general term for a quadratic, it looks like this, an squared plus bn plus c. So in this situation, for this particular one that we are dealing with over here, this one will be equal to 2n squared, your b is negative 3, and your c is positive 5. Why is this important? We got our general term. It means we can get any term we feel like at this point. So if I want t10, all I need to do is to substitute 10 in place of n. Even if I want t100, I can go ahead and do that. So let's go ahead and see if we can use our three formula. There's 2a, the 3a plus b, and also a plus b plus c. Let's see if we can use them in other questions like the next one. Let me give you one example. Well, look at this one. We would like to see if we can handle this one without any problems at all. So let's first of all establish if it is a quadratic number pattern at all. Maybe it isn't. So I am going to, let's give space here. Okay, I'm going to do this. And let me make it a bit bigger. Okay, again. Okay, fair enough. So we have to get the differences here. So go ahead, use your calculator, say T2 minus T1, T3 minus T2, and get those numbers. As far as I know, 70 minus 51 should be at 19 over there, and then 95 minus 70, that should be 25, and this difference here now is going to have to be 31. Well, after I get my first differences, I can see they are not constant. So definitely this is not a linear pattern. I have to go for my second differences and see if they are constant. So 25 minus 19, now I'm noticing that that's 6, and 31 minus 25, I am noticing that is a 6. All I need is for the second difference to be constant. And once it's constant, I'm convinced that this thing is a quadratic. So now the drag is in finding the next term now. You see, you have to maintain this order. So the short way is this. I always say to get the next term, add these 3. If you add these 3, you should be able to go to the next term. But maybe you're wondering, why should I be adding them? So let me explain why you should be adding them. Notice, if I do add them, I should be able to get 163. Let's say you didn't want to add them. Now, how are you going to get it? You're going to notice that these ones, the first differences have a common difference of 6. So to get to the next difference between the numbers, you have to add 6 to 31. So you're going to realize it should be 37. So you will have to add 37 to 126 for you to get to that number. Either ways, you're going to get to 163 anyway. So I think you can do exactly what, as I said, add 126 plus 31 plus 6, you will be able to get to 163 anyway. So it's the same thing all the time. So that's the next term. Now we would like to determine, so here the next term, generally it will simply be equal to 163 for those 2 marks. I think that's beautiful. Okay, so now let's go ahead and calculate the nth term. You can see we want to calculate now the general term. I hope you managed to keep those things in mind. If you haven't, well, we're still here, you know. We are not too far away. Those are here, right here. Those are the formula we're going to use. I said you say 2a is equal to your second difference. In this situation, your second difference is 6. And then you go and say 3a plus b is equal to your first difference, which is 19. And then lastly, you go and you say a plus b plus c should be equal to 51. So in actual fact, all you have to remember is that I will have to use those 3 over there. Those are the ones that I use. Okay, 6, 19, and 51. Those are the ones you use together with your formula. Well, you don't have to prove this formula all the time. You work out a quadratic. That's the interesting part. So here a is going to be equal to 3. So notice, after I get my 3, I'm going to substitute it there to get my b as well. So that will, 19 minus 9 will definitely be 10. And then on that one, so let me put 3 here. Let me put 10 there and say plus c is equal to 51. I wonder what c should be. Calculate 51 minus 13 for me quickly. It should be 38. All right. So from what we know, the general term is an squared plus bn plus c. So in this situation, we are going to just have to say 3n squared plus 10n plus 38, isn't it? So that would be our general term. As you can see, we are getting used to using our 2a, our 3a plus b, and our a plus b plus c. Please keep that in mind. It works wonders all the time. Well, now that you can use the formula, now I would like to show you some questions that they like asking after you get the nth term or the general term. Now they expect you to be able to pinpoint the position of certain terms. Like say, for example, if they tell you that 4063 is part of this sequence, you should be able to give us the position of 4063. So 4063 in this situation is the term itself. So in place of Tn, you are going to have to put 4063. So in other words, I'm saying go ahead and do something of this sort. Do you see me substituting in that formula? That's what I'm doing. So as you can see, I will do something like this. Now from here, I will be expected to calculate n, which will be the position of the term that we are talking about. So we don't struggle with things like this because we have done quadratic equations already in our algebra. So things like this are a lot of fun to us. So you just have to take 4063 to the other side. I hope you won't have many problems doing that. So when you take it to the other side, it's actually now going to be negative 4025. Interesting, okay? Like this. So now this is your quadratic equation. I don't even want to start thinking of the factors of 4025 after I multiplied by 3. So I'm not going to worry myself like that. So I'll just go to this formula and say, well, minus b plus or minus, we are solving for n, isn't it? B squared minus 4ac over 2a. Well, because this is our first example, I'm doing this, I'm going to show substitution. So your n in this situation will be minus 10 plus or minus square root, you know, your b is the coefficient of n, isn't it? And then your b squared, it means it will be 10 squared minus 4 by a of 3 and c of negative 4025. Okay, something of this sort. I just have to say over 2 by 3 like that. So it should work easily. Okay, so let's use our calculators as fast as possible here. Well, if you're using it as fast as I am, you should be getting 35 with a positive value. So that should be the correct n value. And you're also getting another n value. Okay, good. I like it when the other one is not a natural number. That will tell you that whatever it is not the solution. So n is not equal to this. When you get the number or the position of a term, it has got to be a natural number such as this one. So this one will be the correct one that we are using. So in other words, it is T35 really that is equal to 4063 according to us right here. So it should be easy to see. I hope you're getting the hang of this. But before I just quickly ask you, let me give you one question for practice. Let me give you one practice question quickly to do, and do it. You pause the video and you do your practice question, and then you can come and check the answers. Well done if you did the sum. So here is what we've got this time around. I'm just going to copy it down, and then 85. So what I said was, before you do much, you want to get the differences, you know, and write those things down. So the numbers are quite big, so 33 minus 16 should not be a problem. And then this one is 23 here when you say 56 minus 33. And then you seem to have 29. Okay, let's just put 29 over here. So as you can see, those ones are not constant at all. So you have to go ahead and get the second differences and hope that this time around, because the question actually told you that it forms a quadratic sequence, you are anticipating the second difference to be constant. So if it is not, you should start worrying. So here I'm getting 6, and also I'm getting 6 on the other side. So perfect. You know what the first question asked you? You were asked to find the next term. Well, if you remember, I said to get the next term, just add these ones and get it. I think I explained as to why you should do it that way. So you should get 120. Otherwise, if you're that person, you just have to add 6 to 29 for the next difference, which should be 35, and then add 35 to 85, whichever way makes you comfortable, as long as you're getting the solution. So write down the next term. The next term would definitely be 120 here. That is the answer you were supposed to put for that 1 mark. Well, for number 2, you're noticing that you are supposed to get the nth term. So to get the nth term, you do not waste time. 2a is equal to the second difference. You know that it is these terms that we use for the Tn. So if those terms are available, go ahead and use them. 2a is 6, your a becomes 3. And then 3a plus b is equal to the first difference. Okay, and then a plus b plus c is equal to the first term. All right, so let's simplify this one. I'm going to put 3 in place of a. There it is. Oh, look at that. So do we have 17 minus 9 as our solution here? I think we should be able to get 8 as our b value. All right, so if I go and substitute these 2 here, so that's a 3 here, and that's 8 over there, and we should be able to get to what we want. So in this situation, I'm noticing that 16 minus 11, we should get 5 in that respect. Well, I managed to get my Tn, so let me write it down quickly. Just don't forget to write this one down as well. You know that you substitute it into this formula. This is the general formula. It's just that each quadratic pattern will have its own a, b, and c. So otherwise, the general formula is the same all the time. Okay, so it's going to be plus 8n plus 5. So I'm getting this one as our general term. However, you also had a third question you had to answer. Which term in the sequence has a value of 2080? So now on number 3, you were told, well, Tn itself, there is a term which has got a value of 2080. And what position is that term? That is what you were asked. So, like I said, you just go on and substitute this Tn into the formula right there. So, in place of Tn, notice I'll put 2080, and everything else I copy it as it is. 3n squared plus 8n plus 5. Again, it's a chance for you to use a trinomial, a quadratic formula in this situation. So it's going to be 8n, right? What is 5 minus 2080? Well, we just have to subtract 5 from 80 here. Okay, that is what we will have. I will just go straight into substituting into the quadratic formula. I talked about it before. So it's minus b plus or minus square root of b squared minus 4. Our a in this situation is 3. For ac, our c is minus 2075, like that, all over 2a. And our a is 3. So in this situation, I'm going to be able to get my 2n values. Normally, the other value should just go away. So 25, I have a feeling this should be the one right here. Or your n is equal to, okay, I'm getting negative 83 over 3. Well, it's both negative and it's not even a natural number, so this is not the solution. So this is the position of 2080 right here. It is T25, which is equal to 2080. So I hope you'll be able to use your formula for quadratic number patterns. Your 2a is equal to the second difference. Your 3a plus b is equal to the first difference. And then your a plus b plus c is equal to the first term. Thank you very much for watching this video. Let's go to something else. on these quadratic number patterns.